Hey, we're starting our last unit. Now, here's the thing. This was one of the last units in geometry, which means that you learned it during a pandemic while your teachers were still trying to figure out how to teach virtually. So you might not remember this. So what we did in Algebra 2 is we decided to go low level. We're just going to remind you of geometry things and do a little bit of the Algebra 2 level. Normally this year I teach you that there's 3 other functions. It's not just sine, cosine, and tangent. There's also secant, cosecant, and cotangent, but we're going to skip that this year. So if you go on to pre-calculus, just know that it's not my fault. I'm not teaching it to you. They're going to have to teach it to you there, okay? Now, the one thing you might remember from trig is that it's SOHCAHTOA, but you might not remember what that means, or maybe you didn't even understand what it means. So each of these are for sine, cosine, and tangent, and this is the part that tells you what it equals. So sine is the ratio of opposite over hypotenuse, cosine is the ratio of adjacent over hypotenuse, and tangent is the ratio of opposite over adjacent. I'm going to write that all down. Now, what is opposite, adjacent, hypotenuse? What does that all mean? Let me show you. So in any right triangle, there's sometimes going to be an angle that I either need or want. Now, when I'm standing here, this is my point of view, is at the angle. I'm standing where the angle is. The side across from me is the opposite side. The side that the hippo can sit on. This is why the hypotenuse is my little class mascot or whatever. That one's the hypotenuse, and I'm going to spell it wrong because I spelled it right over here, so it's fine. And then the one I can slap, this bad boy right here, that's the adjacent side. Now, I just want to point out, maybe you didn't understand this in geometry. If I'm standing here, if the angle measures here, the opposite and the adjacent actually switch sides. So if I'm standing here, the opposite one for me is this one, and then this would be the adjacent one I can slap over the hood of the car. All right. Also, I forgot to tell you, this symbol right here is called theta. It's a Greek, and we use it for angles. So angles are almost always going to be Greek letters. In geometry, angles are always capital letters, but it's the same thing. It's okay. So we have an acute right triangle where sine of the angle is 4/7. We want to find cosine of the same angle. It's not going to give you a picture, so we actually have to draw it. So let's do that. Okay, now bear with me. I know it says acute right. That just means that this one's right and the other ones are acute. So don't judge me for these two words that are opposites together. I know. So sine of theta, I don't care where theta is. It doesn't really matter. So I'm going to put it up here because I did it in the opposite way before. So here's my angle. So that's where I'm standing. And then I know opposite, hypotenuse, adjacent. I'm always going to just label my triangle. Now I know that sine is 4/7. 4/7. And since sine of any angle is opposite over hypotenuse, then 4 is the opposite and 7 is the hypotenuse. So I already know 4 and 7. Well, if I want cosine, I need the adjacent side. So how do I find the adjacent side? Well, we're going to use, not trigonometry, sorry, we're going to use Pythagorean Theorem. So here's a reminder of Pythagorean Theorem. So in Pythagorean Theorem, we do a squared plus b squared equals c squared. Now c is always the hypotenuse, but a and b can be either way in the adjacent or opposite sides. So the two legs. So we can say that 4 squared plus b squared equals 7 squared. C is always the biggest one. The other two doesn't really matter. 4 squared is 16. 7 squared is 49. I'm going to subtract the 16 from the 49, and I get that b squared equals 33. Well, then b equals the square root of 33. So that's the adjacent side. So what that tells me is that cosine of my angle equals the square root of 33 over 7. So here's the other thing we can do in Algebra 2 is to solve a triangle. Now solve, just like in geometry, means to find all missing sides and angles. And when I say find, I don't mean like there it is, that, BS. It's not a YouTube video. It's gonna be on the internet forever. Sorry. So I don't mean to find like, oh, there it is. There's the missing one. I mean actually figure out the length or the measure. So when I have this, I'm going to start using colors. I wish I did that earlier, but it's okay. if this is angle A, then this is side length A. We use capital lowercase. If this is angle B, this is side length B. And if this is capital C, this is lowercase c. I know they look the same. I hate them too. It's okay. So what I need to find is side A, angle B, and side C. Those are the three things that I need. Now, angle B is actually fairly easy. So for angle B, I got stuck in my head. I wanted to write measure of angle B, and then the B turned into an M, and it just became a mess. For angle B, remember that all triangles add up to 180. And by all triangles, I mean that the sum of the angles in the triangle. So what that means is that 90 plus 28 plus angle B has to equal 180. Like that. And I just do a little bit of math, and voila. Okay, now for angle, or not angle, for either side A or side C, I need to use SOHCAHTOA. It doesn't matter which one I start with, but the other one I'm not going to use SOHCAHTOA on. I'm going to use Pythagorean Theorem. So let's just say that I'm going to start with A. Now, if I'm starting with A, hold on. I say hold on like I'm not going to just pause it and then you won't even know I was gone. If I'm starting with A, then this is the opposite side. This is the hypotenuse. This is the adjacent side. Could I use B? Absolutely, because I know what B is now, but I don't need to because I already have this one I know, and I might have messed up somewhere in here, so I kind of want to start with what I know. So if that's the case, then I want the opposite side, and I know the adjacent side. So out of SOHCAHTOA, the one that has to do with opposite and adjacent is TOA. So this is for A. So I'm going to use tangent of 28 degrees equals opposite, which is A, over adjacent, which is 15. Now, you probably remember in trig that you were confused about whether to multiply or to divide. This one, 15 is on the bottom, so I'm going to multiply both sides by 15 to get it to be away from the A. If the 15 was on top, then we would need to do division instead. So in my calculator, I have a fancy dancy calculator. I can do 15 times tangent of 28. And I need to make sure that I'm in degrees. I'm going to tell you why actually today. So I got 7.97 or 8, I guess. Because if I round that, it'll be 8. And a phone calculator, where's my phone? Yes. I don't think I paused it when I said I don't like writing this, and then I got distracted. Okay, so A is 8. B is 15 equals C squared. Great. So 8 squared is 64, 15 squared is 225. It is. I just checked. So 64 plus 225 equals C squared. If I add those together, I get 289. And I run out of room, so then I take the square root, and C equals 17. Let me just make sure. 17. And I did it. That's it. I found all 3 missing parts that I needed. And it almost always does follow this. We want to find the missing angle using 180, find one of the sides using SOHCAHTOA, and then the other side using the Pythagorean theorem. That's what we do. That's how we do it. Okay, pretty please email me if you're still confused. Plus, we'll do some more of this in class, I bet. And I'll see you next time.